Welcome back to the deep dive. So if you've ever used AI for something, a bit more complex than just ordering a pizza, like say you're trying to summarize a scientific paper or pull specific data from a really dense PDF, you've probably felt that little bit of terror.
Oh yeah, that is this real moment.
Exactly. We're talking about vision language models or VLMs that have to read these messy, multi-page, real-world documents.
And the VLM gives you an answer, and it sounds so confident.
It sounds perfect, and you're left thinking, okay, did it actually read that part of the document, or did it just make something up that sounds plausible?
That's the core anxiety right there.
Well, our sources today are aimed at ending that anxiety for good. We're doing a deep dive into the next generation of what's called visual document RAG systems.
And specifically, how new research is making this whole process completely trustworthy. Yeah, and I think the key word here is verifiable.
Verifiable. Because that lack of trust, that's the biggest thing stopping these systems from being used in really high-stakes fields,
Mhm.
right? Like legal or science.
It's the single biggest roadblock because, the systems we have now, they just give you the final answer, the what.
But not the process.
They don't show the step-by-step thinking. They don't point to the exact spot on the page for every little thought it had along the way.
So we're not just talking about the AI saying the answer is on page 10.
No, no. We need to see every single step it took. And for each of those steps, we need like a digital highlighter box around the evidence and the page number.
Without that, you have zero transparency.
Exactly. And reliability just plummets, especially when you're dealing with documents that have complex layouts, tables, charts, you name it.
Okay, so this brings us to the breakthrough. It's a new way of thinking called chain of evidence, or CoE.
And it's all implemented through a new framework they've built called Look As You Think, LAT.
Look as you think. I love that name. It really implies the AI has to show its work, literally as it's thinking.
That's the massive conceptual shift. Because, you look at the source material, real-world documents are messy.
Totally. You've got columns, tables, flowcharts.
Right. And older systems, some early examples like Visa, they might link the final answer to a source, which is good.
But it's not enough.
It's not enough. It doesn't show you the progressive steps the AI took to actually build that final answer.
And this is where I think the human analogy is so helpful for you, the listener, to really picture what's happening.
Oh, absolutely.
When you have to answer a complex question from a document, you don't just, magically find the answer. You go from coarse to fine.
Exactly. If I'm looking for a data point in a dense paper, I'm not reading every single word from the start.
No way.
I'm looking for the chapter heading first, maybe a figure or a summary paragraph, and then only then do I zoom in on the specific number in the table. I'm localizing the evidence as I go.
So if chain of thought, CoT, is the AI kind of thinking out loud with text,
Right, the internal monologue.
then chain of evidence is the AI showing its work on the document itself, page by page.
That is a perfect way to put it. CoE unifies that text-based reasoning with guaranteed visual proof. Every single thought of the chain has to be grounded.
Grounded meaning what exactly?
It means it has to be tied to a specific visual region, and that's defined by two things: a bounding box around the evidence and the page index it's on.
Wow. Okay, but that sounds incredibly laborious. The idea of training a model like this, manually drawing a box for every single intermediate thought, that sounds prohibitively expensive.
And that's the billion-dollar question, isn't it? That's the data bottleneck. Training this kind of thing usually takes these massive, costly, human-annotated data sets.
Hundreds of thousands of examples, probably.
Easily. So the Look As You Think framework, LAT, was designed specifically to get around that problem with a really efficient two-stage approach.
Okay, let's get into those two stages, because if this is going to be practical, the efficiency is everything. They started with a base model, Quinn 2.5 VL7B instruct.
Right. And the goal was to teach it to generate these CoE paths on its own. So stage I is what they call cold start training.
A cold start.
They needed to get the ball rolling somehow. So they took a small sample, just 1,000 instances per data set, and used a really powerful proprietary model, Gemini 2.5 Pro, to generate the first draft of these traces.
So it generates the text reasons and the first draft of the bounding boxes.
Exactly.
Okay, but hold on. I have to be a little skeptical here. If you're using a powerful AI to generate the training data, why not just use that data? Why the extra steps?
It sounds like it should work, but it's a necessary quality check. They found that even the best models, when you ask them to do this very specific task, they're prone to what they call bounding box drift.
Meaning the boxes just sort of in the general area.
Or it's completely irrelevant. So they
Yeah.
didn't trust it. They had humans manually verify, correct, and filter all that generated data. And get this, they threw out around 70% of it.
70%. So 7 out of 10 of the AI-generated proofs were junk.
Pretty much. Either the visual evidence was wrong or the answer itself was inaccurate.
So that high-quality 30% that's left, that's what they used for the first round of training, the supervised fine-tuning, or SFT.
Right. And SFT is great for teaching the model the format. It learns what a CoE trace should look like.
But it's kind of like rote memorization, isn't it? It doesn't learn how to reason on its own.
You got it. It struggles to generalize to new documents or new layouts. It memorizes answers. It doesn't learn the strategy of looking. And that's why stage 2, the move to reinforcement learning, is so critical.
Okay, this is where the real learning happens.
This is where it learns to think for itself using a refinement process with an algorithm called GRPO without needing that constant fire hose of human-labeled data.
So the RL stage is the secret sauce. And specifically, the rules they set up, the reward system. If that's the only thing guiding the model, it has to be incredibly smart.
It has to be meticulous. And you're right, let's focus on the 2 rewards that really enforce this idea of verifiability and prevent cheating.
I'm always interested in how you stop an AI from cheating.
Well, the main engine here is the stepwise attribution reward, or R-STEP. Its job is really simple. Make sure the words match the picture.
Semantic alignment.
Precisely. It confirms that the textual reasoning step the VLM wrote is actually supported by the little cropped image inside the bounding box it drew.
And how does it check that?
They use a whole other model, a multimodal retriever called Colquin-2, that basically acts as a referee. It looks at the text and the image and says, yep, these 2 are talking about the same thing.
Okay, that makes sense. A referee model.
But here's the brilliant part, the real kicker. This reward, this R-STEP, is only given to the model if the final answer accuracy
The final answer itself.
is correct, or at least meets a certain threshold.
Wait, stop there. That's huge. So you're saying if the VLM produces 5 perfect, traceable, beautifully grounded steps,
Yo,
but then it messes up the final answer on step 6, it gets 0 credit for those first 5 correct steps.
that is exactly right. 0 credit. They are tying the process directly to the outcome. The model only gets rewarded for verifiable steps that actually lead to the right answer.
Wow.
It stops the AI from gaming the system by creating these really impressive-looking but ultimately useless chains of reasoning. It's a powerful accountability check.
That is a fantastic way to enforce accountability.
Yeah.
But, models can be clever. What's to stop it from just drawing a huge box around the entire page for every step?
That would be cheating.
Right. The text would definitely align with something in that giant box.
And they thought of that. They built a literal overlap constraint. It's the anti-cheating rule.
Okay, how does it work?
It calculates the maximum overlap, the intersection over union, or IOU, between all the different bounding boxes in the reasoning chain. If that overlap is too high, say more than 50%, the reward gets a massive penalty.
So you can't just highlight the same big paragraph 5 times and call it 5 different steps.
You can't. It forces the model to act like a human, to move from a coarse, general area to a finer, more specific piece of evidence.
From the table header to a specific row to a single cell.
That's the idea. It enforces evidence diversity and really makes it look as you think.
And then just to tie it all up, they have a final grounding reward, R-ground.
Yes, that one just makes sure the final answer's bounding box is also super precise, with a high overlap with the actual ground truth answer. So the journey is perfect, and the final destination is also perfectly located.
Okay, the mechanism sounds incredibly robust. So let's talk about the proof. Did it actually work?
The results are pretty compelling. Compared to the basic VLM it was built on, LAT showed some massive gains.
In terms of what? Getting the answer right.
Yeah, first in just getting the answer right. It got an average gain of about 8.2% in soft exact match. So it's just plain more accurate.
Which is good. An 8% boost is solid.
Right.
But for you, the listener who needs to trust this thing, the real story is in the visual proof, right?
Absolutely. The evidence grounding precision, that's the IOU score, it saw a massive 47.0% increase.
47%.
47%. I mean, think about what that means in practice. That's the difference between an AI saying the answer is somewhere in this paragraph versus...
It's this number right here in this box.
Exactly. That number directly translates to verifiability, to auditability.
Now, what about the efficiency problem? The whole reason for this 2-stage process was to avoid the cost of data labeling.
And this is maybe the most revolutionary part for actually scaling this technology. LAT got performance that was comparable to models trained on these huge, fully supervised data sets.
The ones with 100,000 hand-labeled examples.
Right. But it did it using only 5% of the raw question-answer pairs during its RL training stage.
Wow. Only 5% of the data to get a similar result.
It's a massive cost saver. It basically says we can get this highly traceable, high-performance AI without breaking the bank on manual labeling.
So it's cheaper, it's more accurate, and how traceable was it really? Did it actually generate those COE paths reliably?
They measured that with a stepwise attribution score, or SA. And LAT hit a high average SA score of 57.1%.
So more than half the time, its reasoning process was perfectly structured and traceable, step by step.
Yeah. And it was robust, too, in those tricky multi-page documents where maybe the answer doesn't even exist.
Ah, the unanswerable question, the ultimate test.
The ultimate test. LAT correctly identified no answer, with an average precision of 65%. It's confident enough to say, I checked, and it's not there, instead of just making something up.
And because it's learning a strategy for looking, not just memorizing layouts, I assume it generalizes better.
Significantly better. When they trained it on one type of document, say academic papers, and then tested it on something totally different like Wikipedia articles, it outperformed the standard supervised models by a wide margin.
It learned how to read, not just what it had read before.
That's a great way to put it. It learned the reasoning strategy.
So bringing this all together, what does this actually mean for us, the people who need to rely on this kind of AI?
I think COE and LAT represent a really fundamental shift. We're moving AI out of the black box. You don't just get an answer anymore.
You get the receipts.
You get the full, verifiable knowledge path. You get the answer, the tech steps that led to it, and for every single step, the precise visual evidence. It just creates this incredible accountability in the system. It turns the VLM into a transparent research assistant.
And if every answer you get from an AI that
Yeah.
reads a document comes with that kind of guaranteed step-by-step proof, it completely changes how we interact with this technology.
It does.
It means you can audit the AI's homework. You can finally, definitively confirm that it isn't just hallucinating the core data,
It replaces blind trust with actual proof.
which is what this field has needed for a long time.
Okay.
So for our final provocative thought to leave you with, let's look at the next big challenge.
Right.
The source material notes that LAT is mainly trained on single-hop evidence. That means the answer usually comes from one concentrated piece of evidence.
A pretty straightforward lookup, basically.
Right. But now, imagine a much harder question. A question that requires pulling data from 3 different tables, using a formula from the appendix to calculate something.
And then comparing that result to a projection in a chart on a totally different page.
All scattered across maybe 7 different pages. That's true. Multi-hop visual reasoning.
That's the next frontier.
So the question is, how much harder is it going to be to train an AI to build a single, flawless, verifiable chain of evidence path when the answer requires weaving together 5 distinct, scattered visual elements and proving every single connection between them? That complex synthesis is where this gets really interesting.